All right, David Costa, the Renegade Aviator, ladies and gentlemen, we are back. All of us, you, me, everybody, we got 10 things to do and enough time in the day to do 5 things. So what I wanted to do today is start you off on a brand new project that we're doing here at Renegade Aviator. And I'm going to be joined by my crew chief extraordinaire, Tye Erwin. Tye, welcome to the Renegade Aviator Show.
Thank you, Dave.
Tye is we allowed Tye to be at home for once in his life between his work and going to the hangar. I think we need to install a bivouac area at the hangar. So when I'm out running around, going all over the place, Tye has been busy on a project, and the project is something that's been near and dear to my heart for a while, and you wouldn't be an aviator if you didn't understand angle of attack. So the Iskra Jet that we fly at air shows is an interesting aircraft, to say the least. It's why we have the only Iskra flying at air shows right now, I think. And it dawned on me when I'm flying the aircraft that there's an opportunity there to educate at the same time that we have a load of fun flying air shows. So what I did is I reached out to a company that I have been a longtime supporter of and what they're doing, and we'll mention them in a second, to install an AOA system into the TS-11 Iskra Jet. And when we talk about angles of attack and things of that nature, there's basically 3 critical angles that we need to realize or understand as a pilot. And it's the pitch angle, my angle of attack, and my flight path angle. And those 3 may or may not coincide at any part of an aerobatic performance, certainly, and just in regular aviating, regular flying. And something that we're doing more and more of here is upset prevention and recovery training. That's a plug for a new project that I won't talk about yet. Tye will slap me if I talk about too many things too far in advance. So this is a preview. All this podcast is a preview of what we're going to be doing. So there's the whole thing we talk about, upset prevention and recovery. And there's 2 elements to that. And the first priority is to prevent the upset from happening, prevent that uncommanded flight from happening. And that can happen on a base to final turn. It can happen on a loss of thrust on takeoff. It can happen with an upset due to wake turbulence or weather or anything. So the priority is to prevent the upset from occurring in the first place. And then once you're in the upset, realizing that we had a startle event. If I become upset, that's different than an aerobatic maneuver where I'm planning that maneuver. But if I become upset or an uncommanded flight situation, I need to react immediately because it's already too late, right? I've already become upset. I need to act immediately to recover. So when we talk about angle of attack, what is angle of attack? Well, angle of attack is the angle between the chord of the airfoil and the relative wind of the aircraft. And I'm going to do more on this on later events. We're going to bring the president and CEO of our new partner on in future events. But the AOA, the angle of attack, determines if the wing is stalled or not. Okay, so, and both of those are critical, by the way. And again, I'm not going to turn this into an upset lesson. So the, some aircraft have a lot of other devices that my Iskra does not. Some may have a flight path vector, a flight path marker, velocity vector cues, all this stuff on modern high-tech jets and fighter aircraft all play a role into aircraft AOA. But again, that's a subject for another video. So the AOA on the Iskra, we want to be able to show you at air shows and on our testing events, which are coming up soon with these videos, where we're going to show you what the aircraft does at, before, and after critical angle of attack is exceeded. So we went out to Alpha Systems, and Mark Cornyn, who's been fantastic with us, Alpha Systems, we went out to them and I said, look, Mark, I love what you guys are doing. You guys seem like you have your act together. And he is passionate, as I am, about AOA over airspeed. So a lot of people say, well, if I'm making a 45-degree bank turn, I'm going to add 10 knots and I'm going to be safe. And that has little to nothing to do with what AOA does to your wing. So we went out to Mark. Mark was kind enough to partner with us, and the reason why Tye is here, because Tye so far has been the leading force behind working together with Mark at Alpha Systems and putting this system into the jet so we can start doing some videos and some demonstrations. And even later, the nth stage of this is you'll get to watch me fly air shows over my shoulder and look at what the AOA does while we're flying an aerobatic performance. So, welcome, Tye. That was my long 6-minute introduction. You see, I'm not one, shut up, show up, be excellent. Well, evidently, shut up is not part of my game. So, Tye, I want to turn it over to you here for a second. Kind of explain what you've gone through. I handed you a box full of shit. And I said, Tye, figure this the hell out because it's plug and play. And I'm going to turn with the words plug and play over to you, sir.
So it was Dave came to me with this and he said, hey, I'm using this in the Gulfstreams. I've used AOA gauges in the airlines. And I said, this sounds like a great idea. The Iskra is a very, she's got a very unique wing. It is, as it's been explained to me, she flies and is designed like a jet. And Dave has said in his intro that he has been in situations where he's had the Iskra at safe altitudes and he's flying the jet and he learns something every time this jet goes up. And I said, well, that makes total sense. But what's the wing doing? And he said, that's what the AOA is to help me do. And he said, the exciting part for Dave was, as you said, is this has a heads up display. I can look through the front window and it will tell me exactly what my wing is doing on this. So I'm sitting there, oh, that's great. And Dave said, yeah, it's been told to me it's plug and play. Well, naturally, when somebody says plug and play, I always raise an eyebrow. But we have the system that Dave handed me was the Eagle system, and it is for the pressurized side because the Iskra is pressurized, and has modular units that also incorporate the expansion box for flap configurations because even though I am just a private pilot and basic for the most part, the expansion box allows for flap inputs for, as we all know, changes the angle of attack in different flight configurations. So this started to lead to other things of, well, one of the challenges that we have with the Iskra is she's not exactly, she doesn't like short fields. So what we're looking at is well, how can we improve safety, reliability, and improve the aircraft through modern systems? Well, this is where we started going down the road of the AOA and saying, if Dave can maintain a certain angle of approach at a certain speed, he doesn't need to take his eyes off of what he's doing in the pattern. He can go right into a field looking right through the screen, and the AOA is right there in his field of view. And so we started looking at this, and I said, okay, well, how are we going to start this project? Because we knew there was going to be challenges because it hasn't been put in Iskra yet. Not a problem. Challenges is something that Dave and I tend to thrive on. So what we started to do was the first thing anytime we start a project with this jet is we go to the book and we start opening things up and we start looking at things, how to come up with how to solve this challenge. And we don't necessarily look at challenges as problems. We look at them as how can we make this work and it fits all the parts for what we want to do. So in this case, in the picture that you see here, this is where we started. The first portion of it was, where are we going to mount the AOA probe? And it went back and forth from the nose to out on the wing to different locations. How are we going to pass through cables and wires and whatever else systems through the pressure vessel? Well, after a lot of discussion, one of the simplest things was, well, we should do it through the simplest way to install this thing. Well, simple isn't necessarily best. So what we decided to do is we talked to Mark and we said, hey, here's the wing and here's one of the ports, and this is on the right wing is what we're looking at, is the outboard just inside of the wingtip, and it is completely unobstructed from airflow that far away from the airframe. We had questions about putting it in the nose cone, but it's fiberglass out there, and the nose cone is completely removable from the aircraft. Well, that poses other problems about disconnecting wire harnesses and all this other stuff, just as simple to do certain things. So I started looking at this open port that we had out here on the wingtip, and it's just literally inboard of one of the stabilizations that's actually on the right-hand screen there. The leading edge of the wing you can see there, that is the tip on the wing. But we have on the Iskra, it has for flutter, it has counterweights that extend beyond the leading edge. So I started looking at the size of the components and the space that we needed for these parts. So on that started to, okay, how are we going to move forward? So what we started to look at is right there, as you can see on the wingtip, is, all right, what size how can we put the parts in here? Yes, we can. What kind of interference are we going to get from other electronics? So
Yeah,
on that, Dave.
Yes, sorry to butt in on you there. I was muted, so I was sick. But what Tye is, he's, I just want to start this out is that we had originally approached an avionics shop to do this, and Tye stepped up and said, "Look, I've never done this before." But I'm willing to give it a shot. And what we say around our shop is shut up, show up, be excellent. And so I want to give you all the kudos, Tye, because this, as you said, but I'm just going to kind of puff you up a little bit that, you step forward. This was not a simple process. And not even for an avionics shop, because we've had avionics people look at this and turn around and walk out of the hangar. Because of the differences in this aircraft and what we needed to have done. So kudos to you, Tye, for reading the manuals, understanding, asking questions. There was some trial and error in this. So anyway, I didn't mean to interrupt, but you weren't going to pat yourself on the back, so I am. There you go.
No, and I just want to, I appreciate that, Dave, because you definitely know I'm not an avionics guy. And so there was a lot of head scratching, but what I realized is there was support behind it. So Mark, we talked to Mark, he's gone way above and beyond. This is the install plate where we had Mark had actually mounted the probe for us. And the metal work and the engineering and just the install even surpassed even my greatest expectations. One of the big challenges of the Iskra was how you get something that's 16, 18 feet away into a pressure vessel. And the Iskra's wing is extremely thin. And I'm not going to get into the hardened details, but one of the things that I highly encourage you, if you do look at purchasing an AOA system, if this is going into an existing airframe um, or an experimental aircraft like the Iskra is do other things while you're in there. In this case, I started the annual while I was in there because I had to drop multiple panels, look for pathways, how are we going to route this stuff. And a lot of the pictures you see in here are just the layout of the wires. It's not the final install of the wiring and all that. But there were a lot of things that had to go into just the small challenges of routing things. There's a lot of moving parts in an Iskra wing, and we had to have custom wire harnesses designed by AOA and Mark. And he said, "Oh, it's not a big deal, no problem. Just do this, this, and this." Very outstanding support. He even gave me his personal cell phone if I really ran into challenges. Everything you see in these pictures is associated with the Part 43 and the maintenance of the FAA regulations, along with Mark's requirements of install. This picture shows the install of the probe out in its laid configuration. And it was, okay, these air hoses need a 4-inch minimum radius bend. Well, 4 inches is pretty tight. But it also afforded us some ability to move around. But a lot of it was, again, it wasn't necessarily, I would say, plug and play, but there was a lot of what you see there of mounting parts. Is this going to interfere? And then there was some head scratching. And then one thing that Dave and I do really well is if somebody gets frustrated or whatever else, is we stop what we're doing, we back away, and we just get some fresh air and maybe perhaps a different set of eyes or get a different perspective. And that what happened is that gave you a minute. It broke what we call a thought process, and you're moving forward. Some of the pictures you see here, we're moving into the actual inside of the Iskra and how the systems get integrated into a system that's been in service for 40 years plus. And I really tried to go into the details of what systems I could use in the existing aircraft and what I couldn't. One of the challenges I saw was because we plan on taking the Iskra into this new world, was I started to discover a lot of shoddy work of what had been done to the aircraft previously, and it was literally classic cut and just unbelievable butchering, especially in wiring. But again, what it did is these projects gave me a chance to go into the airframe and look at some of this stuff and rework work that had been done. And I mean, some of this stuff was literally classic butchering and it gave me an opportunity to just redo things while I was in there. One of the biggest challenges, where are you going to mount this stuff? And this is all part of the plan. Before any of this started, I was reading through Mark's work. He says, come up with a plan, read the plan, stick to a plan. If it doesn't work, you go back and you start over the plan again. In this case, this picture shows where I mounted the system. It's both visible, it's serviceable, and because of the type of system that it is, it can be, you can do adjustments to it in its place. Anybody knows who works in aviation is literally, Dave can attest to you that I have literally almost gotten stuck in the cockpit of the Iskra trying to move stuff around and just to do an annual inspection. It's extremely tight in there. Everything has to be thought about in terms of where things are going to be placed.
I've got a photo. I've got several photos that I failed in my duties here as the host. I've got Tye with feet sticking out of the cockpit of the aircraft. We'll put those in future videos because I always find it extremely funny when that happens. And and my fat ass, if it goes in the cockpit head first, you're going to need a hoist to pull me out. But what I wanted to show in this picture, totally unrelated to AOA, that, ladies and gentlemen, that black handle with the multicolor rainbow of design is the pressurization control for the TS-11 Iskra. That sits behind me off my right hand. I can't see it at all. But that's how the pressurization and canopy sealing and all that works, the heating and air conditioning. There you go, baby. That is 1960s jet technology. I'm sorry, Tye, go ahead.
No, you're good, because what that, and that was the thing is that gets into things about these installs is, and I can't stress this enough, is knowing that Dave cannot see that pressurization handle. I had to think about where all his systems that he may need to reach for did not interfere, that this system that we installed did not interfere the normal function of the aircraft. For instance, I had to figure out where we were going to put circuit breakers and all this other stuff, because there's very limited space in the Iskra for modern circuit breakers and everything else. It does have circuit breaker switches. The problem is when you look at that and you're trying to identify, what am I going to put in here? This picture, for instance, is the pitot heat for the Iskra, and we utilized just a relay to kick the AOA system's heater off of this switch. But to make sure that the whole system worked was, okay, we have to provide power to the system for all this. The interesting thing about the AOA system is it's actually made up of a couple of systems. Its heating elements are completely separate from the actual module itself. It's not standalone, but they integrate together. One of the big challenges, and everybody who's ever worked in electronics, is where's the bus? Well, that's it right there. The fuses are non-primary systems. And it was, okay, how am I going to get wire in here? And as you can see, people have been in here in the past, but that was one of the biggest challenges, is where is the, okay, if there's a positive bus on one side, there's got to be a ground bus somewhere on the other. And so you're doing a lot of tracking of what's going on with, what does this system do? In this picture here, what we did was we've got the pitot heater switch right there. And if you scroll down there, Dave, the far right breaker switch in that picture, it says mag comp. We don't have magnetic compass anymore in the jet. So I said, well, why can't I use that switch to just activate the AOA system? Because it's got its own breaker system, which isolates it from everything else. Well, it makes perfect sense, because he turns on BAT1, BAT2 generator, AOA comes online, and it's all checklist based. So,
Well, yeah, we actually have a magnetic compass. It's a different style now. So that switch, the Polish had a monstrosity of a system to run a quote unquote magnetic compass. So everything on this is, it's not, we're dealing with an antiquated aircraft by today's standards. So yeah, there's a lot of switches that we are stealing for other purposes, including some secret things that I really want to talk about, but I won't. Okay, Tye, continue.
no, and if I misspoke on the, yes, we do have magnetic compass on there. This is just old stuff that was, that we're not utilizing anymore, and it's been removed from the aircraft because it's been replaced by modern avionics. So anyway, this is a picture of the ground bus, and the Polish were very clever. They tend to isolate things well away from other areas. So on Dave's right knee is where all the power bus is. On Dave's left ankle, the ground bus. So everything is completely isolated. And the way I decided to wire this thing was, is well, just find any suitable ground and plug it in there. Well, I'm not an electrical engineer, so maybe we ought to just string the wire where we need to, take the time, get the right connectors, do it right. Um, and if you could go back to the last picture, I'll just talk about something real quick, Dave, is
This one?
in the one just the previous.
That one?
That's it.
Okay.
Yeah. So what I'm getting about earlier in the podcast was, as you scroll up, you see these little wires that are going through. That's the kind of stuff that I was cleaning up while I was in there. And I highly suggest, if you're doing this to your own aircraft or you're building your aircraft, and you have these little nuanced things that are an annoyance. In this case, these wires do several. Some of it's avionics, but I won't get into it. But it was cheap and easy and just classic laziness to just go right in front of the panel in the pilot's view. The problem is it's abrasion susceptible. And it's like, that is no bueno. That is the last thing I need Dave to worry about in his face, is seeing wires rub and arcing and everything.
Well, this is typical, right? So we see this on a lot of experimental jets, a lot of experimental aircraft. This half-assed run a wire, and we're constantly looking for stuff. When Tye and I look at other people's experimental jets, getting ready to test run another aircraft, we find this kind of janky stuff all the time. It looks minor from the photo, but you remember, we're flying an aircraft at almost 500 miles an hour in front of a crowd. We do everything we can to always second guess what could fail, what could go wrong, and fix it. And, routing a wire behind a metal panel that rubs on it constantly because you were too lazy to take the panel off and route the wire. Anyway, a little bit off target from what we're talking about here. But yeah, we got a couple of minutes. We'll just start wrapping it up, and I'll scroll through and let Tye guide you, because I'm really thrilled with the amount of work that you were able to do so far, Tye. This is amazing.
So, one of the biggest challenges that I had with this whole system was where I was going to pull power. It's just one of the big things is, yes, it's time consuming. In this case, this is our avionics bus. But going in and building a mount. How am I going to mount this stuff in? What can I utilize in the existing airframe? I like to use existing airframe holes and everything else. And lo and behold, the Alpha Systems, the way it was laid out and the way the Iskra was built back in from the 1960s, all of a sudden, this stuff started to unfold before me on how easy it was to actually build a mount for it, lay it out, and use existing holes and just some minor hardware. I didn't even have to drill into the airframe. And it really became, all of a sudden, things just unfolded right before my eyes. And all of a sudden, here's all this stuff. One of the biggest challenges with pressurized airplanes is we had a challenge here where all of a sudden the cannon plug, as it passed through the pressure vessel, the little pin you see in the right-hand side there, the alignment pin, when they put this pass-through plug in through the pressure vessel, it's literally oriented 180 degrees from the outside. So we were starting to have issues. Why is this system not working? What's going on here? And there was a lot of taking apart and putting back together. And sometimes, again, you just got to get out of it, get out of the hole, break, take a tactical pause, look at everything, and realize, oh, this is what's going on. The numbers don't match up. But one of the biggest things, and I can't say enough, is I didn't cut any major harnesses in any of this. If you've ever been in modern aircraft, you will see loops of wire in these systems. If you don't need to cut wires and do splices, better for it, because these systems like their signals. But all I can say is if you get into a jam, sometimes it's best to just step away, take a look at things, and solve problems. These pictures you're seeing here is moving into the next phase of the IO expansion module, looking at how to integrate it into the flaps. And the Iskra has an interesting power supply system to the flaps. More challenges. Sometimes you just overlook the minor things in terms of, oh, wow, that's pretty simple. And other times the simple things are just sit there and make you scratch your head. And this is where we're at currently in the install. As you can see, I'm dealing with very old, antiquated wiring. I cannot stress enough that you need to be gentle. If it doesn't go together easily, stop, back up, go easy. There's nothing worse than having to do all this stuff, but you can see the old insulation around there. That's old rubber back from the 1970s. It's as old as I am.
It's younger than me. That's really great. But yeah, and this has all been repaired. So these are things that you don't normally come across, or guys take them out. So not only did Tye rewire in some of the things we need for our IO module, but there was a lot of work done here. You see some insulation that's dry rotted because it's old. And you see how they wrapped everything. Everything was done by hand on these aircraft. It's all been modernized on the way back into the aircraft. That is not burn marks, by the way. It looks like it, but it's not. There's no heat given to that. It's just, these old experimental jets when you get into them. We're just showing you the ins and outs of this thing. We're kind of coming to the end of our timing here. And I just want to show you real quick, again, some more of the stuff Tye was able to do. He learned, did a great job protecting everything and creating cables. But it turns out to just a real quick little snippet, just so you see it, all the hard work. Yeah, there's the HUD. It actually lights. And so that's a great point to maybe stop and show you guys what I'm trying to do here. Let me remove that from the screen and you get to look at Tye and I again. How about that shit? Tye, I just want to thank you because this is a good primer here. We're going to show you all this stuff from a whole new spectrum. And we want to hear from you. What do you want to know about angle of attack? What do you want to see? What types of information do you want? We're going to be developing test cards, and there's going to be some trial and error on the calibration process of this whole thing. So speak to us, like us, share, join in the conversation. Get on with us live because we're going to start rolling here. I'm going to bring Mark Corin on, who's the president and CEO of Alpha Systems. And I'm going to have Mark and I are going to have a conversation about AOA. And I want you to see his passion for safety. So AOA is about flying the aircraft correctly. Renegade Aviator is about being an aviator, not a systems manager. But we can't do what we do without the crew, and that's Tye. That's the entire crew is Tye, except for my wife. But I don't know, she's somewhere in the hangar here lurking. She's my flight attendant on with this airplane. So, Tye, you have anything to kind of wrap up with it on here?
No, just have a great week all. It's been a tough week for aviation, but we're trying to improve it and keep the RPM up, and we'll see you all soon.
All right, man, that's cool. And I thought I had a video here. Wait a second. Hold on. I'm just, I got to run my own board here. But no, I don't have it. I thought I had a really cool video, but I don't. So, all right, man, we are out. It's 34 minutes. I went long, so my responsibility there. This is David Costa with Tye Erwin. I am the Renegade Aviator. See ya.